Hi everyone. I want to do a test of jewelry that I received from two different companies that I ordered online. First we have the Aladdin's Cave jewelry. I ordered two rings. So the first ring is an engagement style ring, 6-prong. It's supposed to be titanium and emerald. The second ring I ordered from them is supposed to be a titanium wedding band. And the other company, Oxford Ivy here, this is a titanium band. Now, what I noticed about the Aladdin's Cave jewelry, none of the rings are marked which metal that they're made out of. They have no markings on the inside whatsoever. The Oxford Ivy is actually, looks like it's laser engraved Oxford Ivy titanium inside the band. So what I want to do is I want to actually check to make sure, are these rings actually titanium? And how we're going to do that is we're going to do a density check, which is kind of easy. We're going to use a scale, a cup of water, some thread, and a little bit of math. So what we're going to do, turn on our scale. We're going to check to make sure our scale is accurate. So I have a 100-gram calibration weight here. It's reading 1/100th of a gram off. And this is a 500-gram calibration weight. We're reading 1/100th of a gram off. So for this test, to tell the difference between metals, 1/100th of a gram, we should be okay with that. That's going to give us a very small margin of error. So what we're going to do is we're going to use some black thread, put a cup of water on the scale, we're going to zero the scale out. We'll do the wedding band first. So what we're doing is we're measuring the difference between how much water this displaces against how much it actually weighs. So this is displacing 0.65 grams of water. Now, if we zero out our scale and we take the water off the ring and we measure it, the ring is 5.27 grams. So 5.27 divided by 0.65 gives us 8.1. Now, titanium has a density of 4.4 to 4.5. So right now we're getting almost double that. So we can be pretty sure that this is not titanium. Let's try the engagement ring. We'll first weigh it. So we have 2.17. We're going to put the cup of water back on. Zero our scale. Put the thread through, and so we get 0.32. So we're going to divide by 0.32, and that gives us 6.7. Oh, actually, it's going to went down to 0.29. So we'll redo the calculation. Divided by 0.29. So we're getting 7.48. Again, titanium has a density between 4.4 and 4.5. So we're way off. Way off. Now the Oxford Ivy, which is actually marked titanium, what we're going to do is we're going to zero out our scale. So we're getting 2.77. Zero. We're going to zero our scale out now. And we're getting 6.0. So we're going to divide this by 0.60. And that gives us 4.6. Now, titanium, like I said before, has a density of 4.4 to 4.5. give or take the depending on the alloy, if it's pure titanium or if it's an alloy of titanium. Pure titanium is 4.4. So even given a small margin of error, the Oxford Ivy comes in correct. It comes in at 4.6. So we're really close to titanium. So we can be really confident knowing that this ring is titanium. These two, on the other hand, are coming in at 8.1 and 7.48. So we'll call that 7.5. Now the stone will actually throw the density off a little bit because emerald is much less dense than titanium, so it will throw off the readings. But again, this stone was supposed to be 1.5 carat. It's not going to throw it off that much. I believe that these two rings are made of the same metal, which is not titanium. Now, stainless steel comes in right around 7.9 to 8 density-wise, and these are real close to that. And there's a lot of jewelry floating around that's stainless steel. And this kind of looks a little bit like it. Now, you make up your mind for yourself, but I'll tell you this. There's no way in hell that these two rings are actually made out of titanium. It is impossible. If they were closer to 4.5, maybe. But they're nearly double the density. Impossible for these two rings to be made out of titanium. Well, I hope you guys learn a little something from this video, and a little bit of something from these two sellers. Anyway, have a good day, guys.